Ronak and Prithviraj Bharti, can you hear me? Prithviraj Bharti, can you hear me?
Yes, sir.
I'm asking Prithviraj Bharti and Ronak.
Yes, sir.
Yes, then why you haven't joined Google Classroom as yet? You have not joined, you have not submitted anything. Ronak, you also. Yes, answer me, Prithviraj Bharti. Ronak, Mayavanshi and Prithviraj Bharti, answer me why you haven't joined Google Classroom as yet. You both haven't appeared for test also. You haven't appeared for test also. There are few students who haven't appeared for test. Arjun, Decan,
Yes, sir.
why you did not appear for test?
Sir, I gave test.
Your response is not submitted.
So some problem.
That is from your side maybe.
Yes. मैंने तो टेस्ट दिया था.
Then it is not reflected to your
Okay.
then I will give you names. Okay, after this class, those people I haven't received responses from those people. So please work hard and attend today's test with all due concerns without fail. Okay, we are having test today, so you please attend that without fail. I'll be giving, I will be posting names of students who haven't, from whom I haven't received responses. Okay, those students must attend this test and next test without fail. Otherwise, they will be in big trouble. Whatever the problem was, you know better.
Mark, sir, Mark.
Marks is not required to be given to you.
इंग्लिश में दिए सर इसलिए
हाँ,
इंग्लिश में दे दिए
कोई प्रॉब्लम नहीं. I will give after, if possible, if required, I will give after 2 tests. Okay, let us start then without wasting much time. Okay, we have started. We have started projection of isometric projection rather. Okay, we will continue with that. Okay, is my screen visible?
नो सर
It's visible now?
Yes, sir.
Yes, sir, visible.
Okay. Now we seen this last time. How can be different isometric projections can be. That is the regular isometric is the very basic one. This one. Okay. Then we have reverse axis isometric also as well as long axis isometric also. But generally we deal with these. These are also there, but they are used in special cases only when you need to show some other features which are not being covered in this view. For example, if some details are here in this side, then you will have to switch the respective view. Fine. Now we will proceed further with these. Okay. Okay, now this figure shows isometric axes. Which are those? These isometric axes. It can be asked which are the isometric axes. Isometric axes are, or say what are the angles between isometric axes. Then you should know what are the angles between respective isometric axes. What are the angles?
90.
Yes, you may tend to speak 120, but it is not 120. That is the we that angle is this one between three lines along which we draw isometric. But for drawing purpose, what we do is it still visible my screen?
Yes, sir.
Yes, sir.
Okay. So now this figure illustrates isometric lines also. I will mark this. Okay. This is isometric lines. Then isometric planes. Hold again time faces. Isometric lines, isometric planes. Fine. Isometric axes, non-isometric axes. Now, in isometric drawing, true length distances can only, this is very important, you note this down. In isometric drawing, true length distances can only be measured along isometric lines. Okay. The lines which are parallel to the isometric axes are called isometric lines. Okay. Now here is the definition given. The lines that run parallel to any of the isometric axes is called isometric line. Any line that does not run parallel to the isometric axis is called non-isometric line. Okay. The non-isometric lines include inclined and oblique lines. These are inclined lines. Okay, they do not run parallel to either of these three. Fine. And oblique lines, we have seen what oblique means. Now, if this is the regular shape of an object, then oblique can be like this, where axis is inclined at some angle. That is called oblique. Okay. And cannot be measured directly. Instead, they must be created by locating two endpoints. So what is done that they are directly joined by locating the endpoints. We need to draw other structure, other component, and then we directly need to join those lines. And by doing so, we will be able to do that. Okay. Now, is that yellow markings are still visible on the screen? Hold a minute. Now is the screen visible?
Yes, sir.
Okay.
Yes, sir.
Okay. So we seen what are the isometric lines, what are non-isometric lines, what are isometric axes, and what are the isometric lines that are parallel to the isometric axes. Okay. Now here this figure on the right side, I'll just point it out. This figure shows isometric drawing of a cube. Okay, the three faces, these three faces, 1, 2, and 3 of the isometric cube are isometric planes. Okay, because they are parallel to the isometric surfaces formed by any two. What are isometric surfaces? Those are which are formed by any two isometric axes, like this. This green is the isometric. This plane here, whole plane, can be termed as isometric plane. Understand? And now isometric surface, and the plane which is in isometric surface is called isometric plane. Here we have three isometric planes because they are parallel to the surface generated by isometric axes. Okay. Now, planes that are not parallel to any isometric plane are called non-isometric plane. This is the non-isometric plane because it is inclined at some angle and it is not parallel to any of the three possible isometric planes. Not these, and neither this bottom surface. Fine. So this is the difference between non-isometric plane and isometric plane. Okay. Now, we will see how hidden lines and center lines and dimension lines should be given in isometric drawings. Fine. In isometric drawings, hidden lines are generally omitted. Where in orthographic projection, we show hidden line. Fine. For those objects which are not visible from particular view. So we show some hidden lines. But in isometric drawing, it is omitted unless they are absolutely necessary. For example, this. See, we couldn't have, if we wouldn't have shown this hash line, then this detail would have been missed. Fine. But if it was like just a simple square prism, then I need not to show that dotted line backward. Now this is fine enough. I need not to show that. Understand? We need to show hidden lines in isometric view only if it is necessary to describe the object. Fine. Otherwise, if this was not available and this was the only detail available there, then this must not be shown. This is understandable. But why this is shown in this particular case? Because we wanted to show these. That's why. Only one purpose. See here also, we are not showing that dotted lines, which will go through like this. Dashed line rather, not dotted. Actually, if you want to imagine, it will be like this, isn't it? Correct or not? This whole plate, if you assume made out of the glass, then it will be like something like this. Then this would have been something like this. Holes will also be there. Correct?
Yes, sir.
These would have been like this, but we don't show these details because these are understood in 3D. Also, see, this is very easy to understand. You are drawing orthographic projections. Fine, you all have done that thing. From where you have done that orthographic projection? From given 3D picture only. That is isometric view only. Was that view showing you dotted lines, dashed line? No, because understandable objects are there, then we don't show that. Okay, these things are understandable. Yes, it will be through only if there is some variation in this hole. For example, it is ending somewhere in solid, then I would have shown that if thickness is this much and my hole is up to this only, then I would have shown that. Here it is understood that hole is complete, through hole. This hole is also through hole. This will be automatically, the depth will be there. This same depth will be back also. That is fine, understandable. That's why we don't show that. Okay. So most isometric drawing will not have any hidden lines. Fine. And that's why, see, we wanted to show this detail. Understand? And to show this detail, we had to give this dotted dash section also. But to avoid this dashed line isometric view, you should select such a viewpoint out of earlier I showed you 4 viewpoints you could draw. You select such a viewpoint that every detail is visible without incorporating this dotted thing. Fine. Okay. But however, if some isometric viewpoint cannot be found which clearly depicts all the major features and hidden lines, and that's why we need to use them. But mostly it is avoided. Okay. Next, center line. Center line I show only for showing symmetry. Now this is symmetric object, all three. That's why we are showing center lines. Understand? Or for dimensioning they are shown, because we at two times we need to show dimension also, like this. If this is the dimension, then we'll have to show it like this. For example, it is from here, not this is 35 for example, then I will show that through center line only. I won't show from anywhere else. The center line normally are not shown unless and until they are showing symmetry or dimensioning. Fine. Because the main objective is to communicate this with non-technical people and non-engineering purpose only. These views are mostly for non-technical people and non-engineering purpose, because they will be shown that this like this your object will look like from outside. They don't require to go into detail. But orthographic projections, orthographic views are required because they will ultimately help us in designing and manufacturing any object, any device, or say any vessel. Okay. Now dimension lines and extension lines and lines being dimensions shall lie in the same plane. What do I mean by this? That this is dimension line, fine. This is extension line, okay. And this is the line being dimensioned, okay. This. So these all three must be in same plane. See, you can see here. I am showing these dimension that it should be parallel to these, and in this direction only I should write my 15. Understand? Same way, this dimension I am showing, okay. So these are called extension line. I will clear my screen and I will show you extension lines. These are called extension lines. These, then these, because we are using that line, those lines for a dimensioning purpose, extending. Yeah, otherwise we could have shown it here, but it is avoided. That's why this thickness or say height is taken by drawn by extending these lines. These two lines are extended, which is ultimately showing this height, nothing else. But we avoid generally to dimension within the uh, block itself, or say within the isometric view itself, fine. So all dimensions and nodes should be unidirectional. See here, you can see it from one direction. We have two methods of dimensioning, unidirectional and align. In orthographic, we can use either of them, whatever is convenient to you, or otherwise say it to you. But in isometric, we follow unidirectional only. Understand? Reading from bottom and drawing upward. Okay, and it should be located outside the drawing, so it does not interfere in actual drawing, and we don't get confused by that. Understand? That's why it is brought outside the actual object, but it is unidirectional. That is the main thing. Okay. And the text, if there is any text, something like these, or say three. Now this through, what does it say? It says that this whole is throughout this object till this plane. This object is hold. Okay. Bottommost portion. It is, if I show you the front view, it will be, sorry, top view. It will be something like this. Okay. Something like this, and this hole will be through hole. There won't be any material. That is what this is saying. Now this R, what is this R? Now pay attention here carefully. See, we are having four features: 1, 2, 3, and 4. Fine. That's why only one dimension, one feature is given dimension, that is R5. What does it say? That this radius is 5 mm. This radius is 5 mm. And we are having such four features. We need not to mention each and everything. Okay. So please keep this in mind. One more thing, if I am having, if you are having some flange, now you will learn later on what the flange is. It is like a disc, okay, like this disc, which is having one hole, center hole. I will rather draw with now this kind of component is called flange, wherein here four bolts are there. These are two flange. One pipe is connected over here. If you see the side view of this, it will something look like this. wherein this is pipe, open pipe. Fine. And we are having hole over here, so we'll show that by center line. Same way we are having one hole over here, one hole over here. Okay, so this is one flange with pipe, and similarly we can have here also the other flange, other side of the flange, which is also having some pipe with it. Fine. So they are connected together. It is called flange joint. They are connected using these bolts. Now here we are having 4 bolts. So we need not to dimension all them 4. What we do, we take the dimension. This is how it is given. That is M. That is not to be bothered by you as of now. M15. That is how bolts are written into 4. 15 mm diameter metric thread 4 number, and you will just mark it like this. Okay, similar to this. We need not to mark in each and every bolts. Got it? Understood? Okay. Now we will see isometric view of some of the standard shapes. Fine. Now the first shape we are having here is square. How it will look like in a isometric view. For example, we know in orthographic etc. First we start with XY line. Okay. Here we start with this line, one horizontal line from 1.30 degree line this way, 1.30 degree line this way. So this is also 30 and this is also 30. Fine. So how we can draw this? That this is 30. So we need to wait a minute. I will change the color. Okay. So this is 30. So we'll draw one line parallel to this on this only 30 mm. This is 30 degree. So 30 mm. Then vertical height it is square, so that's why again 30. So we are having this axis like this also, we know that. So we'll draw that parallel to this 30, again parallel to this line 30, and parallel to this line 30. So ultimately we will get this shape. Got it? See me. Sorry. Okay, so actually we do have these axes. Fine. So tell, first of all, answer me, how many planes are there here? How many planes are here? How many planes are here? Answer me. This is our standard setup. I will clean everything. Wait a moment. Now, this is our standard setup, isn't it? Like this, a corner of a box, wherein these are the isometric axes. What are the angles between these isometric axes with each other?
60.
Huh?
90.
90. We
90.
just discussed in previous slide. It is 90. This is 90. This is also 90, and bottom also we will be having this 90 between this line and this line. Bottom. How many faces are? How many planes are there?
3.
Total
Three.
In in this setup, what isometric setup we have? Standard setup. How many planes are
Three
there?
plane.
3.
3 planes, correct. See, we are looking from this way. Then first plane is this right hand side plane, correct? So it is called right hand vertical face. Or other is this one, which is called left hand vertical face, correct? What is the third face?
bottom.
Bottom, very good. So that is the top of the cube or say bottom of the cube. Okay. If we see the top cube, cube from top, you need top face. Otherwise, you will start from bottom, then it will be the bottom face. But ultimately, it will be horizontal plane, isn't it? So in that, if you want to draw that square, how you will draw? Again, simple thing. First of all, 30-degree line, 30-degree line. Why this coming 30-degree? We have discussed it in first class. So then we will, I will change the color. Okay. Now from here I will mark 30. This is 130, one side, this is one side. Now we are seeing from top, okay, assuming that it is lying on bottom side. I will draw that thing what we are drawing right now. Now we are seeing from here and we are drawing this A, B, C and D. Top surface we are drawing, okay. So how it will look like in 2D when we will be seeing from this top. So this is 30. Now we will mark 130 over here and from 130 over here. So you got all the points and join them. And all the lines are parallel to this axis only, isometric axis is only. Correct? So this is how you can draw different squares. Fine. Now we'll see another shape. Now rectangle, same, nothing changes. Okay. Right hand rectangle. So how we will draw that? Anyone speak up? First step.
Draw one horizontal line.
Very good. Next. Draw 30-degree line on this way. Draw another 30-degree line this way. Correct? Now what is this dimension? 30. So right now we will assume that it is on right hand side face. So this will be 30. Now I will again change the color. So this is 30. Okay. And the vertical height is 50. So we will draw these up to 50. These also up to 50. And we will join this. So you got this, correct? Similarly, if you are having this on the left hand face, then this is the origin, this is 130, from here it is 50, this is already 50, and you join it. Got it? Now assume that if we are seeing some rectangle in top view, then how we will do that? For that, we will draw these lines. Okay. Now in rectangle in top, either one side it can be oriented. We'll see both the ways. First of all, I will clear these things. Okay. So for example, we are having 30-degree like this, 30 mm this line and 50 mm this line. So again from here parallel 30 and join this. Or we could have it on other side as well. For example, this 30, this 50 parallel to this line like this, parallel to this line like this. So this is our object. Got it? So this is how we can draw it. Main thing is these lines are drawn at 30-degree. Okay, and it is directly main dimension, the true dimensions. I told you earlier we discussed it. True dimensions are drawn parallel to this axis as it is. This is 30, then this is also 30. This is 50, and this is also 50. This is also. Like this. Okay. Now we'll see triangle. Okay. Now for triangle, first of all, see the angles are here. Angles are given. Fine. Now to draw the triangle, generally what is done, you first of all prepare that parallelogram. Okay. So this is 30. So what is done? Assume this is a horizontal line like this, like this. So what we will do, this is 30 square, so we will draw this 30 from here, 30 up, from here 30 up, and then we are having like this. Okay. Okay, so this is the obtain this thing. Fine. And locate the point 1 in the parallelogram such that C1 in the parallelogram is equal to C1 in the rectangle. Understood? How you should draw that? This C1 should be same. Understood? This is how we identify point, this top point. And it is not like that C1. We could have done with this also. Okay. Either way, ultimate thing is that first, anyhow, we need to identify this point, point number 1. How it is identified? Because see, now this is, now why we did this? Okay, understand here why we did this. We are taking the dimensions parallel, two dimensions as it is, parallel to isometric axis, isn't it? Okay, so we don't know inclined, how to draw this inclined. We don't know that. We know that if there is some true line or say horizontal vertical line only, then we can directly resemble them on this isometric axis. But we don't know how to draw these inclined lines. So that what we did, we inscribed this triangle in a square. Now okay, we are having horizontal and vertical dimension only in this square. This is horizontal, we have already marked. Fine. Then this is again a horizontal. So what we will do, we will mark over here, same distance. So we got ultimately that point, and then we will join. So I told you, we discussed it previously, how that inclined line are drawn. They are just drawn by joining endpoints, that's it. So endpoint this was available, so we identified this point and we joined this. With this point available, this identified by us and we joined this. This is how we draw triangle. Same happens on the left hand face also, or say top face also. Understand? All three we can do similarly. But the thing different here is that you can't draw this directly. You need to find this point, end point, and then join your inclined line. That is the thing. Fine. Here we are having straight vertical, horizontal only. Here also we are having horizontal and vertical only. That's why you could have drawn it directly. Understood? Now same happens to this pentagon also. What we will do in pentagon? See, first of all, most of the time, we inscribe everything in square and make it parallelogram. Understand? We make that in parallelogram. Like for example, this is my straight line. This is 30-degree line this way. This is 30-degree line this way. Fine. So this is basic setup. Now, what is the, see, first of all, you draw this parallelogram, pentagon. You know how to draw that pentagon. Then out of that pentagon, what you draw? You draw this line from its base. I will wait a moment. Just so what you draw? You draw this line. Should I change color? Okay. Draw this line. Then from this point, draw a vertical line. Draw a vertical line from this point. Sorry. Like this, and draw a horizontal line from this point. So ultimately you got the dimension of this square. So that this size A, B, C, D parallelogram we now got. So first of all we will generate that parallelogram here. Wait a moment. Got it? We have drawn this parallelogram. Now we know how much distance that A1 is. This is the same distance we will mark over. How to draw different shapes, that is important. This is only primary things are only important. Then all the complex problem we will be able to do easily. So we know this distance, we will measure this with compass and we will mark this over here. That will be point number 1. Similarly, we will measure this distance and accordingly measure the point number 2. Now vertically on this line, point number 5. So we will be having some point number 5. On this horizontal line, point number 4. So we will be having some 4. Then opposite to this only it will come like parallel, the point number 3. Understood? So ultimately we got our pentagon. Got it? Understood?
Yes, sir.
Same operation you can do on the left side of this face, as well as bottom face. If you are having some bottom face only, then on that also the same procedure. What is the prime thing here to keep in mind is that true distances we can take only along the isometric axes. We can't take any uh, intermediate true distance. We don't know that how it will look like, etc., etc. See this apparently. Now I will just because why it is so, that I will tell you now. Now see, this point number 3 was here, but here it is somewhere else because it is at inclined at 30 degree. So we don't know where it will be. Otherwise, if you can find it mathematically, yes, correct, you can find it mathematically, but it will be taking lot of time. Understand? It will be consuming lot of time to calculate the exact distance, etc. Instead of that, this method by inscribing the shape in the square, it is lot easier. Square or rectangle, because we know how rectangle is also done. Fine, there is no point, no hard and fast thing that you need to draw the square only. We have seen square or rectangle, that is a straight line instead. By meaning so, in the front view or say in plane view, only horizontal dimension and vertical dimension, no inclined dimension. That's it. So then we can have these horizontal and vertical distances and we can directly draw this required shape. Okay, just a moment. Okay, understood? Understood everyone how we can draw these different shapes? Yes or no? We have seen the square, the most basic one and most important one, second most basic and most important one, the rectangle, and then using that square rectangle philosophy, we have seen triangle and we have seen pentagon. Understood how to draw these shapes?
Yes, sir.
Now, why I showed you this? Now, just for example, this is the front view of my object. Now, I will also draw a top view. Wait a moment. You just neglect these lines. Understand? This is the front view of an object. This is the top view of an object. Fine. And I will also draw the side view of an object. Just a moment. Now this is front view, this is top view, and this is side view. I'll tell you that I will give you example that draw the isometric view of this, isometric drawing of this given orthographic view. So what you need to do first? You will direct me. I will draw accordingly. What is the first step? Fast.
Draw the horizontal line first.
The horizontal line. Then draw the 30-degree incline this. Draw the 30-degree incline this way. Correct? Okay. Now I am assuming this is my left side. Understand? So I will have to prepare one parallelogram according to the square. Correct? Yes or no?
Yes.
So I will draw it something like this. I will draw. Correct? Within that, I will inscribe this thing because now I know what is this distance. I know this distance, so accordingly I will mark a point number 2. I know this distance, so I will mark point number 1 over here. I know this vertical distance, so I will mark point number 5 over here, point number 3 over here, and similarly I know this distance, so point number 4 also here. So this is it. Fine. Now you know this is the 50 mm, for example. So you draw this line at for 50 mm. Every line we will draw up to 50 mm, parallel to this line. 1, 2, 3, 4, and 5. But instead of that, what is the better? Just a moment. Now, what is the better idea is draw one more, or say draw one more square at 50 mm distance. Understood? So it will be this way, then it will be this way, it will be this way, it will be this way. And now draw the projections. We know how it will work like. Sorry, I'll change the color. This will be fully visible, this will be fully visible up to this line, and this point up to this line, and these up to this line. Understand? It is done because we don't show dotted line, dashed line. Correct? So how we have drawn this? Now this is our solid object. Got it? Got it or not?
Yes, sir.
Is that
Yes, sir.
Yes, sir.
simple? Okay. So I think you are having class at 1:50.
Yes, sir.
So we'll stop here and batch A people, you are having lab, na? Batch A people, we are having lab, okay, after this, correct? So I will send a fresh link, you join by that link, okay? If you want to ask anything regarding this session, first of all, ask me. Any question, anyone?
Okay, sir.
Any question?
No, sir.
Okay.
No,
Thank
sir.
you. We end this session then.